What is wind energy? Wind energy or wind power describes the process by which the wind is used to generate mechanical power or electricity. Wind turbines convert the kinetic energy in the wind into mechanical power. This mechanical power can be used for specific tasks such as grinding grain or pumping water, or can be converted into electricity by a generator. In recent years, wind energy has become one of the most economical renewable energy technologies. Today, electricity generating wind turbines employ proven and tested technology and provide a secure and sustainable energy supply. At good, windy sites, wind energy can already successfully compete with conventional energy production. Many countries have considerable wind resources which are still unutilized. Wind energy is a source of renewable energy. It does not contaminate. It is inaccessible and reduces the use of fossil fuels, which are the origin of greenhouse gases that cause global warming. In addition, wind energy is a native energy because it is available practically everywhere on the planet, which contributes to reducing energy imports and creating wealth and local employment. For these reasons, producing electricity through wind energy and its efficient use contributes to sustainable development. How is wind power a greener option? The beauty of wind power is that it is derived from a virtually unlimited and accessible resource, the wind. Unlike energy that relies on fossil fuels, wind energy produces far fewer carbon emissions and pollution. In addition, most wind turbines or wind farms, once established, don't have exhausting operational costs. History of wind power. In the 1st century AD, for the first time in known history, a Greek engineer Heron of Alexandria creates a wind-driven wheel used to power a machine. By the 7th to 9th century, windmills are used for practical purposes in the Sistan region of Iran near Afghanistan. Panimon windmills are used to grind corn, grind flour, and pump water. This continued for over 1,000 years until in 1887, the first known wind turbine used to produce electricity was built in Scotland by Professor James Blyth. In 1888, the first known U.S. wind turbine created for electricity production is built by inventor Charles Brush to provide electricity for his mansion in Ohio. The giant built turbine has a diameter of 17 meters or 50 feet. It has 144 rotor blades made up of cedar wood operated in a pulley system connected to a dynamo, which generates electricity that flows to 12 batteries in Brush's basement. One turn of the wheel corresponds with 50 revolutions of the dynamo. At capacity, the windmill generated about 1,200 watts of electricity, enough to illuminate the house and about 100 incandescent lights. In 1891, a Danish scientist Paul Lacroix develops an electricity generating wind turbine and later figures out how to supply a steady stream of power from the wind turbine by use of a regulator, a cratostate. 4 years later, Paul Lacroix converts his windmill into a prototype electrical power plant. It is then used to provide electricity for lighting for the village of Ascot. By 1900, approximately 2,500 windmills with a combined peak power capacity of 30 megawatts are being used across Denmark for mechanical purposes, such as grinding grains and pumping water. Paul Lacroix starts the Society of Wind Electricians in 1903. He is also the first known person to discover that wind turbines with fewer blades that spin faster are more efficient than turbines with many blades spinning slowly. Over 100 years, countries adapted in this discovery and started to utilize the wind energy, building larger and more efficient wind turbines that can produce larger power capacity. Wind turbines have developed radically with countries like USA and China, holding the largest power market in wind energy.
How does wind energy is transformed into electrical energy? If we will measure the wind speed at the front and back side of the turbine, we would notice that the wind speed at the front side of the blades, which we will denote as V in, is more than the wind speed at the back side of the blade, which we will denote as V out. According to the law of conservation of energy, energy cannot be created nor destroyed. So, why does V out is less than V in? The answer is that some energy from the wind is transferred into the blades, which makes it turn and rotate. Therefore, the wind will decrease in speed as it passes through the blades of the turbine. Mathematically, we can denote the power converted into mechanical energy as one half the product of the mass flow rate of the input wind minus one half the product of the mass flow rate of the output wind. However, it is important to note that it is impossible to obtain a 100% conversion of the wind energy into mechanical energy because B out can never be zero. In addition, not all of the mechanical energy from the blade's rotation is transformed into electrical energy due to some losses such as heat, friction, and noise. The design of the wind turbine blade. The cross-section of a wind turbine is shaped like an airfoil, which is similar to the cross-section design of the wings of an airplane. The airfoil creates a pressure differential between the bottom and the top surface of the blade. As a result, when the wind blows through the airfoil-shaped blades, the pressure differential will generate lift force, which in turn will rotate the blades of the turbine. Parts of a wind turbine. As discussed earlier, the blade catches the wind, which in turn turns the rotor of the turbine. However, the rotation of the rotor is quite slow to generate a useful frequency of alternating current that we can use as electricity. That is why the rotor is connected to a gearbox. The gearbox is composed of several gears that increases the speed of the rotation. Then, this gearbox is connected into to the generator, which generates the electricity. However, since the wind intensity and the direction is not constant, sensors are placed at the top of the wind turbine shaft that detects the changes in the direction and intensity of the wind. The data collected by the sensor is then fed to the controller. The controller makes adjustments on the position of the blade and the position of the turbine. The controller does this by feeding the data into the yaw motor and the yaw drive, which rotates the turbine platform such that the blade are always facing the direction of the wind, and therefore will increase the efficiency of the wind harvest and the converted wind energy into electricity. Where should wind farms be installed? There are several characteristics and criteria that a chosen location must check to be a worthy wind farm installation site. The first is relatively high annual wind speed. Ideally, wind farms need a constant and steady wind speed to generate power. Typically, wind farms are installed near the shore or even on shores and on a flat land facing a windward side of a mountain because these locations are where the wind speed are relatively high and constant. The second is proximity from population centers. Wind farms, aside from generating electricity, also generate a lot of noise. Due to this, most people don't want to live near them. In addition, Some local governments prohibit the installation of wind turbines near residential areas. The third is the surface terrain. The ideal surface terrain should be flat because a hilly or mountainous terrain can block winds, hence reducing the harvest of the wind turbines. The next is the prevailing wind direction or the general direction of the wind in that area. Advantages of wind energy. Wind energy, just like solar and geothermal, are renewable energy, and therefore they are almost infinite and clean sources of energy. But let's discuss the comparison between wind energy and other renewable energy sources. The first is less operation and maintenance costs. The operation and maintenance cost of a wind farm is generally lower than solar and geothermal. The next is less space is occupied. We can infer that solar solar farms can take a lot of space while wind farms generally needs less space, and therefore this space can be used in other purposes such as farming and agriculture. Disadvantages. Wind farms causes a lot of noise. As discussed earlier, wind farms aside from generating electricity can generate a substantial amount of noise. It is because the mechanical action of a wind turbine will generate friction and therefore it will generate noise. The next is the fluctuation in the wind. It is no surprise that the wind intensity and direction is not constant, and therefore it will affect the efficiency of each wind turbine. In addition, this wind fluctuation can make it hard to integrate wind farms, wind energy into our existing grid system. The next is the initial cost of a wind farm is relatively high. As discussed earlier, the operation and maintenance costs may be low. However, the initial cost is high because building infrastructures needed for wind energy are relatively expensive due to its sheer size and complexity. The next is it can become an obstacle for avian wildlife.
Wind energy characteristics. First is wind speed, which it determines the amount of electricity generated by a wind turbine, meaning the higher the wind speed, more power will be generated. Next is wind speed distribution, where it is divided into three patterns. First is diurnal, which affects more on coastal sites than offshore and is caused by temperatures by day and night. Second is seasonal or depression, which affects more in oceanic regions and occurs usually for about 4 days. Lastly is annual, which varies with the degree of latitude. Next for the characteristics is turbulence or short-term fluctuations, which is the rapid fluctuations in wind velocity. Next is distribution of wind direction, which is important for laying out in a wind farm. Lastly is wind shear, which is a changes in wind speed over a short distance and it causes the power of the wind energy to deviate. Wind energy improvements. Here are some improvements done in the wind energy. First is longer blades, meaning it can catch more available wind even on areas with relatively less wind. Second is blades with curved tips, which are able to take advantage of wind speeds, and the rotor will operate at a broader range and generate higher maximum torque. Next is sturdier blades, which are able to withstand the stress of high altitude of the wind. Next is a control system that can either control or optimize the power output. Next is a reliable gearbox, which is used to change the speed of a shaft connecting in a electrical generator. Lastly is digitalization, which is one of the main reasons of wind energy's growth. Current status of wind energy. According to an article published by Global Wind Energy Council, that 1.1 billion tons of carbon dioxide globally have been avoided thanks to having a 743 gigawatts of wind power capacity worldwide. And as we can see in the chart by the Global Wind Energy Council, that 93 gigawatts of wind power was installed in 2020 alone. US and China played a big part in installing new wind energy in their country, which have installed an 18.19% and 55.91% of wind turbines respectively. Future of wind energy. In a report by International Renewable Energy Agency or IRENA in 2019, that onshore and offshore wind energy would generate 35% of total electricity needs by 2050. By that point, 6.3 gigatons of carbon dioxide will be cut. To achieve this aim, the wind energy installed must reach 6,000 gigawatts by 2050. For offshore wind energy, the global cumulative capacity would increase up to 228 gigawatts by 2030. To achieve the said goals and fulfill climate goals of containing the rise of temperature globally, the investment in wind energy needs to be tripled in order to install them. Future of wind energy in the Philippines. Onshore wind energy is one of the largest wind power in the Philippines, making us the most dominant wind energy market. And as of 2020, the Philippines have installed an onshore wind capacity of at least 450 megawatts. According to Mordor Intelligence, that the Philippines has set a goal of achieving an additional of 1,548 megawatts of renewable energy by 2030. In 2021, the Philippines has started three constructions of wind farms in Baloy and Kaunlayan, Ilocos Norte, and in Aklan, Panay, which will be done in 2023. The three said wind energy project would add up to near 300 megawatts of energy that could be generated, with the Philippines having a 11,055 kilometers squared of windy land which are estimated to be excellent wind resource materials. The area can be used in order to construct new wind turbines.